So our next unit, or our next part of this unit, leads off from where we just left. This sum of the angles in a triangle, they add up to 180 degrees. So basically what we're saying, any triangle, if you were to take the corners, and you could do this with paper, rip them off and put them, pointy ends together, they would always make a straight line. They would always make a straight angle or add up to 180 degrees. So we've already used that a little bit at the end of the last section. If you are challenged by listening through my logic behind the logic ones, you don't have to listen to it. Maybe just looking at the key is enough for you to deduce on your own. So, always remind you can use the answer key to the notes or listen through if you do like hearing the work. I added a little extra. This isn't used in the course, but the sum of the angles in any rectangle, square, or technically something with 4 sides, which would be a quadrilateral, would add up to 360 degrees. And so another little piece of trivia, if you ever need to know that, I don't know, it might be a skill testing question when you win $1 million, who knows? That's in there. We will be using this triangle bit as we did in our last logic puzzle. So the first example is all written out for us here, right? Basically, if we know 2 angles in a triangle, we can always figure out that third angle, right? By subtracting what we know from 180 degrees. So that's what we're trying to do in these last ones here. I'm just taking 180 and subtracting what I am told to figure out what angle X is equal to, or whatever's missing on our triangle. And so that's the A. If I show my work on this, I get what angle Y is equal to, or 57 degrees. I could do that another way. If this is a 90 degree, that's already taking up half of the 180. So the other way to get to this 57, I could just start with 90 because I know these other 2 sides need to make up the other 90 degrees. I get to the same answer. This is likely what you're going to do at this point because that's really the point of this lesson. The last one, 180 minus the 44 and minus the 85 would give me what remains, or angle X in this case, and that would be 51 degrees. Pretty simple, pretty straightforward, definitely calculator work, not, super challenging. The next is about classifying triangles according to, what kind of a triangle they are. And so I'm just going to shrink this down a little bit so you can see it all making you dizzy, all on one page. Basically, there's 2 ways of classifying triangles. They all have 3 sides and 3 angles, but we can take a look at the sides of them, or we can classify them by the angles that they have. So a scalene triangle would have no equal length sides. So if this is, I don't know, let's say that's 6, maybe this is 4, and this is 5, right? They're all different. If we had a different kind of triangle where we had 2 sides that were the same, that's called an isosceles triangle. And so these 2 lines here, that there's only 1 across them, is indicating equal sides. The key thing about isosceles triangles, and it's not in the realm of angles, I know, is that those 2 sides are equal and these 2 angles are also equal. So 2 equal angles as well. The last kind of side classification would be an equilateral triangle. You've probably covered this at some point, and that has 3 equal sides. And by the logic that I just introduced, it also has 3 equal angles as well. And if we were to take 180 and divide it by 3, equilateral triangles always have 60 degree, 60 degree, and 60 degree angles in them, always. Because that's the only way you could have equal angles when they add up to 180 degrees. So these are all about sides. The other 3 classifications are all about angles. So if the triangle has all angles that are less than 90, that would be an acute triangle because it has 3 acute angles. So if they're less than 90, they're called acute triangles. If there is a 90 degree, they're called right angle triangles or right triangles. If there's one angle that is really, really big, leaving the other two much smaller, that's an obtuse angle, as we talked about. So this is an obtuse triangle. This angles still always add up to 180, but this is another way of classifying them. So let's try these. There's an array of triangles at the bottom of your page. If we were to, sorry, not being very good at scrolling here, or zooming in, classify them two ways. Let's start with the sides and then do the angles. So this first example, all the sides are different, so that would be scalene. If I were to think about the angles, because it has this right angle in it, this is a right triangle. So it's a scalene triangle and a right triangle. The next one over here, first off with the sides, we have two that are opposite or the same as each other, so that would be isosceles. And because all the angles are less than 90, it's also an acute. Whoops, that didn't work. Sometimes this pen gets away on me. Oh, does its own thing. Acute. I'm sure you've already got it written down. And we're moving on to the next one. A-C-U-T-E. The next one, as far as the sides go, this would be an equilateral triangle. My pens are, pretend that says equilateral. It says equitateral, but that's okay. Taleral, anyway, equilateral. It would also be an acute triangle. I'm at the bottom of my tab. Let me move up. The next one is arguable a little bit, but it looks to me like it would be scalene. And it would also be acute. This one over here would be scalene and obtuse. And the last one up here would be isosceles and obtuse. Two ways of classifying and, two ways of naming them. Okay, we're going to move on and put it all together. So these are some logic ones, and putting it all together using your knowledge, if these two lines are parallel, we now have this additional information that the triangles add up to 180. So if we use that bit of logic, we can start filling in all of these. And honestly, like I was saying in the first section here, I just start writing on the diagram because I might find it easier to figure out some other angles. And you've got multiple ways. So I'd start by saying that this is 50 degrees because it's opposite. I'd say that one is 130 because it would be supplementary to the other 50s. Moving on, I'd label this as 130, even though I don't need to know it. Sometimes it's handy to know. The next thing I do is move up in the Z pattern here, where I know that this is a 50-degree measurement. Feeling a little bit dead-ended over here. I guess I could say that angle 4 is 50 degrees. Every time I do these, I do them just a little different too. So don't feel like there's a right and a wrong. If you get to the answers, you're doing fine. So I went ahead and did a 123 over here. I'm going to do supplementary to that to get my 57. Across from that would also be a 57. The easiest way to get to angle 2 here is to take 180 minus the 50 and minus the 57. That's going to give me an angle of 73 for angle 2. I've got a little bit more information to kind of complete all of this. Whoops, I just changed the number. Careful on that. Copying errors are amazing because then they perpetuate themselves. Angle 3 is going to be opposite to this one, and in order to figure it out, we could take a look at the supplementary angles. So angle 3 would be 180 minus the 50 and minus the 73, so a 57 in there. And just because, I'm going to finish them all up. So we end up with 1 being 130 degrees, angle 2 being 73 degrees, angle 3 being 57 degrees, and angle 4 being 50 degrees. You can try and do them in order, but with my approach where I just label everything that I can, it leaves me versatile in my problem solving strategies because different things pop out to me, different patterns pop out to me at different times. And so that's my approach to these. The next one down here has us indicate a few things. So it says name two right angle triangles or two right triangles in this diagram. And so we have a 90-degree up here and a 90-degree down here. So we're looking for two right triangles. Well, I can see, oops, you know what? I took a line away and now I don't know if you can see, there should be a line across here. Sorry about that. I was trying to simplify the diagram, but I kind of made it not work. So name a right triangle without my drawing, with the notes you have, sorry about that, would be triangle BCD, or angle, sorry, BCD, or angle C, right, as a right. Oh, hang on, we're really messing this one up. It does ask for triangles. So triangle BCD. What would angle, here we go, BCD, BDC equal? Oh, this is what we're supposed to look for here, all right? Y. And then what would angle AED equal? All right, let's give that some look. So we're supposed to figure these ones out. This is where I see, and that's why I added to the notes, the C pattern. If I have two parallel lines, top and bottom here, right? I know that angle 135 and whatever this question mark is down here should add up to 180 degrees. So 180 minus the 135, or the C pattern, would give me an angle measurement of, what did I do here? 45 degrees. The next one, if I were to take a look at the F pattern, and maybe I'll change my highlighter color. So the F pattern here, that makes this angle and this angle equal to each other. And so that tells me that this is also 45 degrees. The F pattern with other angle. All right, so now we know that this is 45 degrees. It says now, an interesting question, is triangle BCD isosceles? So isosceles, what we're saying is that these two sides should be equal. We already have 90 degrees here. I guess an interesting question would be, what is this angle right there? If we did the math on it, knowing that there's 180 degrees, we'd know that this is 45 degrees. So if these two angles are equal, we know that these two sides are equal. And so the answer would be yes. If the two angles are equal, the sides are equal. And the last bit here, line segment CD would be 9.5 centimeters, same as the other one that was given. And line segment BD, oh my, would be equal to this one over here, 13.4. They're going the same angles, and so they'd be the same length, so 13.4 centimeters. One more little bit that I will mention here is that the longest side is always across from the longest angle. And it doesn't really matter, it's not in our notes, but I do find that that's good to catch if I've made a silly mistake. Okay. Using a protractor, I can't have a protractor on the screen, so I did this. Make sure that you find a protractor. Your instructor has one if you need to borrow one. If I were to read off of a protractor, there's two scales. So one starts at 0 and goes that way. And the other one is numbered from the other direction. Basically, if we want to measure this angle in between, we want to make sure that we're starting at 0 and counting up. So that would mean that this angle that is being measured is approximately 45 degrees. It's awkward to read the two different scales, but yeah, that's really the only wrinkle with this. So we have these ones to label. I can't really show you on the screen in the video, so give them a try. Practice using your protractor. I have written my answers to the best of my ability. You might disagree with me by a couple degrees, but if you're way off, it probably means that you're using a different scale. So that's a pretty quick and not a great video for the last little bit of using your protractor. But again, it's probably something that you've done, and the best that I can do is give you that image in your notes so you can see that first one in action. The protractor that I had at home actually had a little hole here, so you could really see where that vertex was and make sure you line it up carefully.